Okay, we're going to look at polar coordinates, and all polar coordinates is something like this. Now, it looks a bit different. This is our Cartesian coordinates, which we're very, very used to, and that can plot a point by going across and then up or down, that plots a point. When we're dealing with polar coordinates, it's the same thing. You need two things. You need a distance from the origin and an angle. So to plot this point here, we might be 1, 2, 3 units away, and we've turned 60 degrees. So they're the two things we need. How far away from the origin? We're 1, 2, 3. And what's the turning? 60 degrees. If we're plotting this point over here, how far away from the origin? 1, 2, 3 again, but we're 195 degrees around a turning of 195 degrees. So there's two ways we can look at positioning something. We can use the Cartesian coordinates, that's the coordinate 3, 4, or the polar coordinates. And when we're dealing with polar coordinates, this point here would be maybe 3, it has a modulus of 3, so r equals 3, and the theta equals 60 degrees. So the modulus is 3, and the argument, well, that's what we call it, is 60 degrees. Over here, we might say it's a modulus of 3, so r equals 3, and again, the theta is 195 degrees. And we could do that in radians as well. So let's have a look at how we switch between the two. Okay, so this is the polar coordinate 3, 4. If we want to switch it to polar coordinates, what we need is that distance. How do we find the distance? That's nice, simple Pythagoras there. So it's 3 squared plus 4 squared, and we take the square root, and that's the way we do the modulus of r. It's going to be the square root of 3 squared plus 4 squared, which is the square root of 25, which is just 5. Nice and simple. How do we find theta, or the angle? The angle in this case is just always going to be tan. Opposite over adjacent is tan, so it's tan the minus 1 of 4/3. And we could do that in radians or degrees, but we probably should do it in radians. Tan the minus 1, so it's shift tan, and it's 4/3. And that is 0.927. So theta in this case is 0.927. Okay, that's the only thing that there's a few more things that we have to think about, but in this case, r equals 5 and theta equals 0.927, and that's in radians. Okay, if we wanted this one, again, the modulus doesn't change too much. The modulus is going to be this triangle here, which is 4 and 4. So the modulus r is the square root of 4 squared plus 4 squared, which is the square root of 32. And we could write that as 5. I think it's 4 root 2 actually. Okay, but the square root of 32. Now, if we're looking at theta in this case, again, if we look at this theta here, that's going to be the tan of tan the minus 1 of 4 over 4. And that is going to be, and again, we'll do it in radians, shift tan, bracket 4 divided by 4 equals 0.785. Now, that was that angle. This angle, 0.785, is this angle over here. That's not the angle we want. We want this angle here. What would that angle be? Remember, in radians, this is in degrees, it's 180. So in radians, it's pi, because pi equals 180, or pi radians equals 180 degrees. So we could do theta is going to be, the angle that we want is just going to be pi minus this theta. What's pi? 3.14 minus the 0.785. And we can just do that on the calculator. Okay, so it'd just be pi minus that. And when you do that, it's just going to be 2.356. and dot, 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 dot. So that's how you change between radians and, between Cartesian plane and polar. And if we wanted to do one more, we could do that one as well. Again, what's the modulus, or the distance away? The r is going to be the square root of x squared plus y squared, which is the square root of 2 squared plus 4 squared, which equals just the square root of 20. How would we find theta? Well, I can find out what that theta is. That's going to be opposite over adjacent. What's the opposite? It is 4 over 2. So again, it's tan. Theta is going to be tan the minus 1 of opposite over adjacent, 4 over 2. It is always y over x. And I've just ignored the minus sign because I'm going to deal with that in a minute. Shift tan. 4 divided by 2 equals, and I'm in radians, so theta in this case is 1.107. But that is this angle. That's not the angle I want. I want the angle right the way around, which is going to be 2 pi minus the 1.107. And I can just work that out on the calculator. 2 pi is 2 times 3.14. So it's 2 times pi minus whatever I just got. And that is theta equals 5.1760. Okay, so that's how we go from that's how we go from Cartesian coordinates to radians and degrees. If we want to go the other way, and we've got these, and we said that this point here would be r, and r equals 3 and theta equals 60. Well, that means the x value is just going to be 3 cos 60, and the y value is going to be 3 sine 60. And we can just work out what that is. Over here, we can do exactly the same. It's 195. Remember, the x value is always, x is going to be 3 cos 195, and the y value is going to be 3 sine 195. And here I'm working in degrees, not in radians. So going both ways, hopefully that clears it up a bit. What's the next thing we want to do, or what's the next thing we will be doing with complex numbers? Well, we need to do all the same sort of things. We need to add, times, plus, and divide. I think that was all of them. So if we're adding, that's really simple. 3 plus 4i, and we're going to add 6 plus 2i. All we do is we add the real parts. 3 plus 6 is 9. And we add the imaginary parts. The 4i plus 2i equals 6i. So 9 plus 6i. And minus is exactly the same. When we're timesing, we've got to use our rules a bit. But if we're timesing 3 plus 4i, and let's times it by 2 plus 3i, we're just timesing. So we're 3 times 2 is 6. 3 times 3i is 9i. 4i times 2 is 8i. And 4i times 3i is plus 12i squared. And you just got to remember about this one. That's all. This is just going to be 17i, nice and easy. This is going to be 6 minus 12. Because I squared is minus 12, because I squared is minus 1. So this is going to be minus 6 plus 17i. And the last little thing is what happens when we divide. When we divide, that's when we've got to look at the conjugate. So let's suppose we had 3 plus 2i and we